This testing first requires the preparation of a test specimen. This specimen is usually with standard measures being a length of 2 inches and a transversal area of 0.5 inches. This specimen consists of two main parts, being on the sides the shoulders and in the middle the gauge. The shoulders are where the machine grabs the specimen, and the gauge is a reduced area in the middle of the specimen.
The Tensile H300KU is a machine that allows the effect of axial tensile stress to a specific material. It's used mainly in tension tests. In conjunction with a computer, we introduce the data of the diameter and the name of the material to be reviewed. We click on the Done button and press the 3 zeros on the top half of the screen. Then we proceed to execute the order of printing results. The Tensile H300KU has a load cell of 60,000 pounds and an extension measurement range of 0 to 1,200 millimeters with a resolution of 0.0001 millimeters with accuracy of 0.01 millimeters to 300 millimeters. The speed control velocity has a speed range testing of 0.01 millimeters per minute to 500 millimeters per minute. The return speed is of 0.01 millimeters per minute to 700 millimeters per minute.
We are now going to explain the process for tensile testing. First, the process for tensile testing initiates with the respective classification of the specimen to analyze. Later on, we proceed to obtain the respective diameters of each of the specimens from the gauge of the specimen. Remember that the specimen is compounded by two shoulders that are located on the sides and the gauge that conforms the body of it. Then we proceed to use the tensile machine Tensile H300KU after checking all the calibrations from the machine. To calibrate this machine, we need to compare the patterns from the chart cell with specific calibration sheet. This process is commonly done by the producer of these machines. Finally, we compare the results obtained from the machine with the theoretical equations in order to obtain a certain percentage error. Note that if the percentage error is less than 10%, it will be acceptable. Otherwise, the user must assume that the calibrations of the machine were not done correctly, producing this way a high margin of error.
We have our graphs of the lab. We're going to proceed to understand the graph and how to work with it. First of all, we have the axis. The y-axis represents the loads that we apply, and the x-axis represents the strength. We have three lines: the red line, the blue line, and we finally have the green one. The green one represents the break point, is where our material is going to break. The yield strength is when our material is going to pass for elastic deformation to plastic deformation, and the red one represents the ideal mode of junk. This part of the graph, that is the black one, as you can see here, is the elastic deformation that we're going on to. The material is not going to deformate. The second one is where plastic deformation occurs, and this is when our material is going to fail. And finally, we have this where it's going to break. After this point, our material is going to break. So we have to be very careful not to choose this point after this, because if we choose, we're going to have that is going to break our material.